Today we'll continue with SQL. So whoever is already aware of SQL, right? Maybe they may get a little bit of boring, but we need to be on top of it. Okay. So to continue with the sessions, right? Yesterday we have seen the different clauses uh, of SQL. And then we can use these arithmetic functions. Yesterday we have seen count, how to get and all, but we can be able to get this sum, average, minimum, max, and everything. So we are just going through the concepts. Once these concepts are done, maybe I have written some queries, use cases, something like this. So we will try to answer these queries. Okay, so this is how business people will look at it. Okay, it's not that select this or something like that, right? So they'll be interested in this, something like this. So suppose products number sold at a full price, so that means, so right from the beginning there is no chance of selling the products with full price. Always they're discounting and providing discount prices, so that means something is wrong there. Okay. And something like this, get customers who bought at least one product in category X but never bought category Y. So the customers who purchases something in category X, maybe that means sports item. So they are always interested in sports item, but they have not bought anything in grocery. Okay, so consider retail domain. Okay, so what kind of customers they are, and how to get these customers into this category as well, apart from this category. Okay, something like this. We'll be discussing all this once we are done with these discussions. Okay. Um, so maybe today we will start with this and we'll see. And assuming you guys are aware of SQL, so I'm taking a little bit of faster manner. Okay, so if you're not understanding, please stop me. And while doing this, right, we'll be having this operators. For every tool and technology, right, you'll be having operators. Like when you are calculating something, when you are applying some conditions, you need to apply these operators, maybe arithmetic operators, logical comparison operators. What does this mean? Maybe let me open this document. Actually, every time it is asking the connection settings. So maybe you need to connect it. If something is missing, we need to provide those details again. Okay, so I've connected to this. So coming back to the slide and the operators section, suppose you want to make some arithmetic operations, like you want to calculate some discount percentage on a product. Okay, and you want to add some points to the existing flag or something like that, right? So in those cases, we'll be using these arithmetic operators, being it in select clause or being it in where clause. So wherever it is, right? So we'll be using this plus minus. These are very common arithmetic operators. And always, it's not only SQL, right? You need to use this across any tool and technology. So similarly, comparison operators. So comparison operators may be based on the tool. It may be different because here equal to will be using single equal to, but in other technology, suppose if it is a Databricks PySpark, so you need to use double equals to. So similar case for Ab initio as well. So not equals to, some cases will be using this not equal to or not, just greater than less than symbol, something like this. So syntax might be different, operator is the different, but functionality is same, right? Okay, so if you want to compare equal to or greater than equal to something like this, we'll be using these comparison operators. So between, in, like, is, null. So these are something, right? So between, it is something like when you are writing some logic. So I want to know the customers range between, suppose this one, salary between 3,000 and 700. So instead of writing salary is greater than or equal to that 3,000 and less than 7,000. So instead of writing something like that, you can use this between operator. Okay. So that is between. And in is something, suppose if you want to get some data based on if my department is in HR, IT, or sales. So in that cases, we'll be using this in class. Okay. Let me show you the example. Unlike is something like matching pattern. So if my name should start with A, after A, any number of characters or anything, I'm interested to know to get those details. Then in that case, we'll be using this like operator. Name like, inside the quotation, you will be writing that particular logic. Okay, so there we have pattern matching, are two things, percentage or underscore. So percentage will tell you any number of characters after that, and underscore will give you a single character. So if my intention is I need to start, suppose I want to get my data of the name, customer name, starts with the A, and something like AND, Andrew. Okay. So if it is something like this, and also I'm interested if Anand or something. So okay. So I'm interested in these three things, these two things, right? So then you can say A percentage. That means after A, any number of characters or anything. Okay. Or I can say A N underscore underscore. That means name should start with AN and the next two characters, because it is two underscores. So then in with this underscore, any character, with this underscore, any character. So that is how, if you want to make uh, replacement with any character, then you will be using underscore. And if it is any number of characters, then you can get a underscore. Suppose I have something like this, A and D R G W. Okay. So when you use a percentage, you will get all three records. But when you say an underscore underscore, you'll be getting only these two records. Okay, why? Because here we are using only two underscores. That means third character and fourth character. Only four characters it is expecting. So likewise, you can use this like operator based on your interest. So you'll be, while working on use cases, right? You'll be getting all these things. Okay, so we'll cover all these things as part of that. And one more thing is null. Null is something undefined. So undefined. So when you say your data is having some null value inside this, that means it is not blank. Okay, remember that. Null meaning it's not defined. So if you say some blank, okay, and you can compare this blank with another blank, but you can't compare null with any another null. So null is not equals to another null, because null is nothing. Nothing you can't compare with nothing. So why? Because nothing is just, it's a black box. You can't compare that black box with another black box. So that is the reason null you can't compare with any other null. Okay. So that is how you can see some data as well. Why is this? Let me create another new one. So instead of depending on that connection name, username is this. Okay, if you see here, size of that particular product, maybe if you can see null. That means the size of this particular product is not defined over here. Okay, and if you see the other columns, so here it is a string column, and this is a decimal column, and this is date column. Okay, so cell start date. So something like that, cell end date. So this product will be ending by this particular date, something like that. Okay. So that is how they'll be creating data types and whether it is null or not. So something like that, they will give you that. Suppose I want to get all the product names which starts with suppose long. So simply you can say, so instead of writing all this, maybe I'll just say star to minimize that, where name like long. So when you say this, it will whatever the name starts with the long, so that will give you that information. Okay. So if you want to comment this, you can do that. Okay, and then is null. Suppose I want to know um, what are the records which has not been provided sizes. So I want to fulfill that and I want to give some sizes against to that. So I want to get all the records which are having null in size. So simply you can go here and you can say where size is null in that syntax, where size. Okay, so all these records, all these products is being given as a size as null, so that I can analyze and I can do something like that. Okay, and suppose color. So if I say I'm not interested in all the products, I'm interested only in some red and black color, where I can say color is color in, and then everything you have to string, right? You have to give inside quotations always. Blue. So all the records which comes under this color is blue and red. So only those brands will come into picture. Okay. So if I say this one is small letter, or small letter is also considering. Okay. Actually, it should not. So why? Because data is case sensitive. So small b and capital B is not, both are not equal. So these things, right? These clauses you can write in capital or small letter, but the data inside your columns, it should be case sensitive. So small b and capital B is not, both are not same. Okay. And logical operators. So this will, when you want to combine multiple conditions together, then you have to say this logical operators. That is and, or, and not. So and will it is something like when you are writing some logic, condition 1, condition 2, and condition 3. Okay, so when you are writing and between these are, so you just need to understand it's a mathematical representation. So when you say condition 1 and condition 2 and condition 3. So when you say this, and always remember, and will give you true. So actually this will give you Boolean value, either true or false. So if your condition is met, that means it is true. If it is condition is not meeting your expectation, that comes under false. So when you say condition and right, so true will come only when all your conditions are true. So then only your total expression will become as true. So that means if I say condition 1 and condition 2 and condition 3, so that means if your condition 1 is true as well as condition 2 and condition 3, so then only your entire expression will become as true. If any of these conditions are false, so that means it is not, suppose you were something like this, right? Salary is greater than 2000. So that means based on your records, if salary is less than 2000, right? So this will give you false, obviously, right? So likewise, if any of these conditions is false, then your expression will become false. So similarly for R, it will be something like if any of the expression is true, if any of this expression is true, then your total expression will become true. Okay. And yeah, that's all. If all conditions are true, then only your total expression will become true, otherwise false. And if any of the expression is true when you are using R, so the total expression will become true. So otherwise false. Simple. Okay. So with that, right, maybe let me go here. Color is color in, and I can say size is null. Okay, so I want to see the products which are color is in red and blue and size by being given as null. So that means, so only these records and as well as this one. So this will give you was being by regards in why color in size is null. I don't know. Okay, so with this, right, you are giving two expressions. One is this one. This expression is true. That means you are getting this, and size is null. So whatever the null records along with this condition, so whichever is satisfied, right? So those records will come into picture. Suppose I'm commenting this and I'm executing this. So when this record comes into picture, right? So this is satisfying this condition, and we are looking for size as well. Size is null or not. Since size is 58 and which is not null, so this record is eliminated. Likewise, these records got eliminated. And whatever the satisfied records, those records will come into picture. So if I say R, R condition, so this will give you all these records again. Why? Because red and blue are being it is size is null or not null. Is this coming like this? Okay, so now apart from red and blue, you can see black multi as well. Why? Because here you can see null for black and multi. So that is the reason you can see these records along with your red and blue. Because this condition is met, so that means this is true, right? So that is the reason you got these two records as well. So likewise, you have to use this intelligently. Suppose I will say something like this: product ID equals to suppose 706 and product ID equal to 707. Okay, I'll say like this. So if I execute this, how many number of records I can see in my output? If I write this logic, how many records I can get it as my output?
Two, sir.
Sorry?
Two records, product ID 706 and 707. Yeah.
No records? Any other answers? Yeah. It will not give you any records. Why? Because remember, this query, it's not only SQL query. If you take Unix, Python, or Ab initio, anything, it will execute record by record. So assume that these are your input records. All these are your input records. So whenever you are writing some logic, okay, so this will take your first record and execute this particular condition or whatever it is, and will give you the to your output. And similarly, this record and execute this output. So likewise, it go record by record. So there are some scenarios where we can apply parallelism or distribution. So that is different. So that is there you can work on records in parallel. But ideally, when you are writing something, it will execute record by record. So with that knowledge, when you write this logic, right? So first it will go here and it will look for something like where condition after a product, right? So where condition will execute, right? So product ID equal to 706. Yes, that means 706 equals to 706. And again product ID. What is product ID here? 706 only. Why? Because still we are in first record. 706 equals to 707. So that means this is true and this is false. True and false will become always false. So likewise, this and a switch operator basically. So this will work something like that. Okay. So when you say this, it will not give you any records. And similarly, if I say or, so it will give you true or false. So that means it is true or false. So obviously your output will become true. Okay. So that is
Maybe that is a string and need to give equal to. Product ID string or
not sure. Is some kind of temporary temporary glitch. Okay, so it gave you two records. Why? Because you are using or condition. Okay, it is just a kind of common sense how to use and all. Okay, so you just need to remember, that's all. So based on the scenario, we will be using all these things. Or not is something like uh, it is just it's not in or not equals to something like that. So if it is something like not equals to 706, so it will give you a hell lot of records, right? So all the records will satisfy and will give you all those records. Other than 706, you'll get all the records. Because here it will satisfy all the records and it will give you, of course, whether it is been given or not, it's no important. It's give you the same output because 707 is not equal to 706. Okay, so that's how we'll be using. How we can implement this kind of things in use cases that that time you will get to know how to use this. Okay, and in the operator we have seen, right? Suppose where name in red and blue. So this will give you all the where name in red and blue. Why is this not giving anything? Name. AMA.
Build region which
Where color, right?
Ah, true. Where color in. So similarly, you can apply not in. So which is not equals to red and blue, all the remaining things comes into picture. So likewise, we will be using the combinations. Okay. So with that, yeah, any questions? Okay. So joins, this is very common required concept across all the tools wherever you are using. Why? Because your data will be residing in multiple tables or multiple files. You need to get the information from multiple tables um, based on your requirement. Suppose your data is something like this, right? Here you can see customer address. This is not giving. Oh yeah, here it is. Yeah, if you see, okay, so if you see here, your customer table is having these fields. So it has maybe customer ID, customer name, some details. Okay. So it is having customer ID, name, style, title, first name, middle name. So something about your customer. So likewise, to which address he belongs to, in which address he is residing, right? So those customer address details will be here. Okay. And the sales details, sales will be here. So product. So product ID, product name, so which category that belongs to, what is the size, weight, all those things will be coming here. And similarly, sales details, so that you can see over here. So what is the sales order detail ID, a product ID, something like this. Suppose this sales order detail is having some details like what are the sales transactions has been done today. So customers, some 100 customers came in, and each customer, one customer, he purchased some 10 products, another customer purchased 1,000 products. So from this particular part, you will not know. So suppose if you see this, you will not know what that product is. We know one particular customer, he purchased this and that, but you will not know what is this product is. Okay. So A36. So he purchased uh, one quantity. Okay, product ID, this one. That price is 356 rupees. There's no discount for that particular one. And this is line total is 356. But because quantity is 1. If quantity is 4, suppose 4, and unit price is 218. So this will become 218 into 4. So that total will come over here. Okay, so likewise you'll be getting it. But I want to know what product is this. So what product this particular sales order ID is representing. So that means you have product ID, but you're not having what is the product name, product category. So all those things you will not know. So to get that, this product information will be available in your product table. So what, based on the product ID, what is that product name and what is that product number, color, all those things you can get it from here. So to get that information, what you need to do, you need to join this table and with the product table, so that you will get to know what is that product about. Okay, so let me join this. Maybe let me. Okay, so while writing your logic, right? So you will need to write your logic something like this. Okay, so what are the fields you are selecting? That we'll see from which table, first table, and this is my second table. Okay, so I'm just giving alias names. Why? Because here, if you're not giving that, right, you have to say something like this. Again, your entire table name over here, something like this. Dot product ID equals to this, something like that. So instead of doing that, what we can do, we are just giving alias name. So S for sales order and P for product. So where my product dot product ID equals to sales order detail dot product ID. So if this is happening, so what is your expectation? So I want to get the product details along with my sales order ID, right? So that is how you need to select it. Okay. So while selecting, suppose I'll execute this. This will throw you an error. Why? Because if you see this product ID, row ID, modified date. So these two just some audit columns, just remove them. So assume that product ID. It is available in both the tables. So when you say just product ID, it will not understand from which table I need to fetch this particular product ID. So that is the reason you have to select based on what is your expectation. Okay. So if you provide that, this will give you the details, something like this. P dot product ID. That means you are extracting product ID from your product, and all the remaining things is coming from sales because those details are not available in your product table. So as we are expecting, what is the product name, color, something like that, right? So then you have to select them as well. P dot suppose product name, name, not product name. Okay, so if I say this, this will give you what is that product name is. Okay, so this is the product name, and that will be part of your output now. So likewise, you need to apply the logic, and you need to get the required fields. So from which table and what columns you are expecting. So those will be part of your set query. Okay, so when you just say like this will be treated as one type of join, that is inner join. So you'll be having based on your interest, you'll be having different join types: inner join, left join, right join, full outer join, and then cross join and self join. Cross join and self join, let it be. So inner join, left, right, and full outer join. So apart from this, when you are working in Databricks, you'll be having a few other joins, that is left semi and anti join. So those things will be discussed. So when you say inner join, so whatever we have applied here, so this will become as inner join. That means when you say inner join, it is only matching records from both. Okay. So whatever the records over here and what are the products over here, if both are exactly matching, so based on this particular column, so this will be composite key as well. So here we just gave a product ID, right? So sometimes maybe we need to give multiple keys as well based on your data model. So who will be creating all these tables, and what is primary key for those things will be discussed. So based on the relation between one table to another table, right? So just at a high level to use giant operators, I'll just tell you. Suppose you are having product table and you are having sales order detail. So how do you know what is the relation between these two? So these two is associated by product ID. So this product ID is key over here, and as well as this same product ID will become foreign key over here. So that means your data model will tell you. So suppose um, at least it will give you at high level, right? Okay, so it is something like customer is one table, product sales date is another table, and salesperson this will be associated with sales table. Okay. And customer who purchased the products. So that will be something like that. Yeah, one. Yeah. So if you see here, the customer table, transaction table, and the account, just ignore this. Customer will be making multiple transactions. Okay. So customer ID. So that will be IDs will be generated to each and every customer for my business. Okay. So that will be unique. Suppose account ID or customer number. Suppose you are using some bank transaction and you are the customer, right? So customer ID will be unique to each customer. So that should not be repeated. So that means that will be considered as primary key. So we'll discuss in detail, but I'm just giving you the high level. So that will become primary key for that particular table, which is not null, which should not be repeated. Okay, it should be having unique records. So that will become as primary key. Suppose this customer table, each customer will be making some transactions. Suppose he has done some debit card withdrawal, debit and deposited some amount into the bank. Okay, and he made some inquiry on some vehicle loan. So all those will become transactions, and those transactions details will be stored into your transaction table. So inside this transaction ID will become as primary key, not customer ID, but because customer may have multiple transactions. Okay. So with that, the relation between customer to transaction, it will be one to many. So one customer may have multiple transactions in your transaction table. Okay. So likewise, it is one to n, one to many. Okay. So that is how customer ID will become foreign key over here, which is primary key over here. So likewise, your data model will be designed by your data modeler. So data modeler will come with this multiple tables. What is the relation from one table to another table? So this is very much important for data projects. Okay, any technology. So this architecture is very much important. If it is not appropriate, right, there will be hell lot of rework. Okay, so that's how this architects, designers, database administrators, data modelers, all these are very much important. Okay, so when you say data modelers, right, it's just a deviating from the actual topic, but it's much required. So data modeler, basically, yeah, they'll come up with some initially they'll come up with conceptual data model. So that means, so based on your business, suppose I'm into retail domain. Okay. So inside this retail domain, what exactly the subjects are, what exactly the different operating models are, different LOBs, line of businesses. So if you say sales is one, customer is one, product is one, and what of product category is another one, and maybe sales you can divide into multiple things, but yeah. So suppose these are the main topics, main business areas for your whatever you are thinking of your business. Okay, so in this conceptual data model, this is the first data model what your data modelers will come into came up with. Okay, so this conceptual data model will talk about what are the different concepts, and once that approval is done, yes, these are the different concepts which will be good to go for our data mart now. Okay, so then they will come up with some logical data model. So logical data model is something they'll create some logical structure. So if you see this is logical structure only. Okay, so they'll say, yeah, this is sales table, and this is product table, and this is customer table, and these will be different field names, and the relation between from this table to this table will be like this. So at a high level, logical level, they'll give you some data model. Okay, so once this LDM is prepared, so this will be discussed with the DBAs, architects, and they'll get the approval. So once, yes, this is good to go, and everything is in line, so then they'll come up with the physical data model. Okay, physical data model. So this physical data model will consist of actual implementation. Okay, actual implementation means what exactly your table name is, what are the different columns inside this, and what is the data type of this, and whether it is null or nullable, and what could be the length of that particular column. So likewise, everything will be decided and everything will be given as a clean as part of physical data model. So this will come into some projects they'll be giving, and some projects we may not get this physical data model. Yeah, so this will be the actual document will be given to the developers, data engineers. Okay, and this one along with the DBA, they'll come up with database architecture. So here you'll be getting all the database tables. What are all the database tables? And this should be in sync. Your physical data model and as well as your DBA architecture should be in sync, so that that will be our inputs to start with the data engineering projects. Okay. Yeah. So that's how the data modeling will come into picture, and that will be the inputs for us. Okay, coming back to the slide. So the inner join, basically, we will be applying the conditions based on your requirement. So here, my requirement is I need to, whatever the sales I have done. So for that, I want to get the corresponding product ID or something like that. So if that is the case, you will be using this inner query. Okay, so sometimes we'll be using this left join. So left join meaning, suppose I want to get all the records from my suppose product table, and what are the matching records I want to extract from sales table. So if that is the case, you can consider that as left outer join. So that means all the records from your left table and only matching record from right table. So similarly, right join is matching records from your left and all the records from my right table. Suppose in this case, right, I'm interested all the products and only matching from sales. That means if you see at the business level, suppose I have 100 products delivered from my business. Out of 100, so far only 95 products sold to different customers and different time frame. Maybe from the past 1 year, out of 100 products, 5 products nobody has purchased so far. Okay, so 5 products it is just sitting idle. So I want to know those details. That means the records which are present over here but not present in this particular table. So that we can get it from join component, join right outer join query, or you can get it from this one minus set operator that we'll discuss. Okay, so there are a lot of other ways to get it. Maybe even you can get it by using in operator. All those things we can see now. Okay, we'll see. You just need to correlate, that's all. So here, this is left table and this is right table. So I'll be using where right outer join on. So this is another way of writing your joins. So if it is something like inner join, right? So you can simply write inner join, this table, inner join with this one on. So this is where you can write it. So this is exactly same as your previous one. So inner join on this one. So similarly, I'll say right outer join on sales on this one. Okay. So if you see here, most probably you can see same as previous, because most of the products got sold. So with that, you will be having sales records over here. And based on this, I'll say where sales order ID is null. yes, dot sales order ID is not. Yeah, spelling mistake. Okay, so if you see here, these many products, okay, which is not sold so far. So if you see, product ID and name will become as values because you are starting from product table, but there is no associated sales over here. So that is the reason your sales order ID, all these things will become as null. So these many products, there is no sales in your sales order table. Okay, so this is how you can apply your right auto join. So what is the difference between left and right? It is just how you are using your tables. So if your this table is become as here and product is here, so left auto join, simple. Okay, so that is how you'll be using. Suppose this same query. So I want to use this same query differently. Okay, so suppose I'll be using this over here, and I'll say we'll be writing this with sales product in. From this table, I want to get the information. Okay, and what is our intention? It should not be available in this particular table. Okay, so what I will do is I will just write something like this, where my p dot product ID is not in. In we have seen, right? So is not in. So which is not in this particular table. So I want to write something. I'll explain you what is this and all. P dot product ID, P dot name from where P dot product ID is not in. Why is this giving like this? Near in. Okay, so actually there are some syntax issues, right? Maybe in Python you'll be having that is here, it will not be. Maybe shell scripting it is different, so something like that. So the concept is same. That's all. Okay, so here what I'm doing is, so the same query, whatever we have written here, but you'll not be getting the output of all this, but you'll be getting only these two over here. So if you want to get that, we can write, but differently. So here my intention is, I want to extract the data. So if I execute only this one, so this will give me all the product ID and product name from this particular product table. Okay, but what my intention is, the products which are not sold. So that means there is no product ID in this particular table. So in that case, what I need to do, where I could say what I can say, suppose it's not there. Product ID not equals to product ID not equals to something 815. Assume that 815. So 815 equal to 815. Okay, so that means I know this product is not sold so far. So when I execute this, obviously I'll get what is that product is. And suppose this product is also not there. I know that. So I can say, since it is two values, you can't use equals to. Equal to you can use it. So something like this. And you have to use this one. Product ID equals to this, or product ID equals to that. Okay, so you can use that and you can get this. Or what you can do, see here programmatically you can't write, right? So you can't say something that this and the or that, something like that. So what you can do, you can simply use suppose hard coded itself. Instead of use, I can say in inside 850, being it is 815 or 736, it will give you both records. But I don't want to hard code like this. Okay, I want to get it this programmatically. Okay, records which are not in this particular table. So instead of in, I'll be using not in, and instead of hard coding the values like this, I want to get those product IDs from this particular table. So I can simply write this. Okay, select product ID from this particular table. Okay, so all the product IDs available in this particular table will be replaced over here. So the way we have written 815 comma 930 something like that, right? So here I have suppose 1 million records. So all those 1 million records will be substituted over here, and this will compare if that product ID is not in this, so that we will be getting all those values. Okay, so here just remember, if you are writing something like this, you can write this kind of queries. These queries you can call it as subqueries. So this is very common writing of queries. You can write it in where condition or from condition or wherever you want. Here also you can write inside the select clause. Okay, based on our requirement. Okay, so by using this one, I got the information. So what are the products which are not sold so far? So that list you can get it. Okay. So similar way, even you can write in set operator as well. So that we'll discuss, but I'll just tell you what it is. So this time you can't use this. Why we can't use this? I'll tell you. Feeder product ID from this one. Minus, there's no minus operator or what? Select product ID from this one. Okay, so this will give you what is minus. I will tell you. Okay, so this is how another other way of getting the same data. So the products which is available here and which is not present over here. So same way we can get it from minus or not in subqueries and then join. Okay, so there are multiple ways to get the things, but only thing is you need to understand the concepts and as well as which is more efficient way. Efficient way meaning since we are working some thousands of records over here, it will be okay. But when you start working on the projects, it will be hundreds of millions of records. Okay, so what are the query you are writing, what are the code you are writing, being it any technology, it should be performance oriented. Okay, so this is how this queries will joins will work. Okay, inner left right, and full outer join is something all the records. So all the records from full auto join, yeah, all the record matching records and left out record from your left table and unmatching record from your right table. So all you can get it from this full auto join. Okay, so there are some situations I want to get all the list of products which has been sold and all the details you can get it from here. If you want to see, you need to remove that. So this will give you this one and as well as yeah, if you see these records as well. Okay, so very much important. If you are confusing, ask me. I'll tell you more, or explore through ChatGPT or YouTube. Okay, so sometimes it will be confusing. So that's what I'm saying. That's where I'm saying. Okay, so there is another concept that is cross join. Cross join is something here. Suppose you have 2 records and here you have 3 records. So when you use cross join, every record will be joined with every record of here. Okay, so there is no where condition or anything. So it simply connects every record of table 1 left table to every record of table 2. Okay, so that means if you see here, I have 2 records over here and 3 records over here. So it will give me 6 records because this will be communicating to these 3 records, and second record also will be communicating to 3 records. So very rare scenarios will be using this cross join. So suppose, for example, I don't see the example from this particular tables. Suppose you have a product table. So inside the product table, you have suppose a t-shirt and you have some shirt and you have something else, A, B, C. Okay, and you have another table which is colors. So colors is having something red, blue, yellow. Okay, likewise. Okay, multiple things. Maybe here you have 100 products and here you have some 10 different colors. Now I want to generate a table which should consist of, for all these products, I want to get these colors. So t-shirt, red color, t-shirt, yellow color, t-shirt, maybe what is that, blue color. So likewise, for every product of every record of this table, I need to capture every record of here. So likewise, shirt red, shirt blue, shirt yellow, A red, A blue, A yellow. So likewise, if you want to make such kind of things, then you will be using cross join. Okay, very good example of explaining this cross join. Okay, so in those cases, we'll be using this cross join. So based on your business use case, we'll go and we'll do that. And another thing is self join. Self join is something, it's not, self is not a keyword or anything. It is just a concept. Suppose you are joining same table. So I have employee table and I'm joining the same employee table again. So if you are doing such kind of thing, that will be considered as self join. Okay, so simple example is this one, like employees table will be having a employee name, employee ID, employee name. Similarly, manager ID, manager name, not manager name, manager ID, something like this, department, something like this, right? Suppose 100. Let me ask ChatGPT. See, if you see here, employees table is having employee ID, employee name, manager ID. Employee 1, he doesn't have any manager. Employee 2, manager's ID is 1, 3, something like this. Okay. So now I want to get my output something like this. Employee ID, employee, and what is his manager name? So if you see here, for Mary, the manager ID is 1, but who is employee? The employee ID 1. Employee ID 1 is John. So that means Mary's manager is John. Okay, likewise, David's manager is John. Anita 2. That means Anita's manager is David. Rahul's manager is David. So to get that, you have to join employee with employee itself. So that you can get it over here like this. Employee ID from employees, left join employees M. Okay, so he is using both employees, the same table, but giving alias names as E and M over here, and employees dot manager ID. So in this case, employees manager ID should be equals to manager dot employee ID. So that means, so if you take this, right, so this employee manager ID should be equals to manager's employee ID. Okay, so when I'm talking about this one, consider this is the record, right? So the employee ID is different. His manager ID is 1. So when you say 1, So this one employee name will be John. So that's how they are applying this join over here. And then we are extracting e.employee name as employee. M is nothing but your manager, right? Manage.employee name will become as manager. Okay, so the data will be extracted from the same table, but alias will be different. Okay, so that's how we'll be using this self join. So why we use left join here is because if you don't use left join, this record will not be coming into picture. Okay, so this record will not be comes into picture because there is no manager ID available and it is not, it is null. So that is the reason left join will is been used. So when you use left join, automatically you'll be getting that one. Okay, that record as well. So that is how we'll be using this. So these are different other examples. So you can go through it. So that's how you just use ChatGPT as well instead of breaking your heads. Okay, but I suggest don't go to ChatGPT for everything. So when you get some use case, initial phase at least when you are learning anything, so don't go to ChatGPT. Okay, so if you know the algorithm, and this is another important point, what I used to say to everyone. So I said something concept wise learning, and I said something, yeah, parameters, automation, automated way of learning. And another thing is, most important thing is algorithm. Your solution will be algorithm oriented solution. So when I ask you, I have your table 1 and I have table 2 and I have table 3, um, which would be the better one to take? List of customers who talked about who ordered products priced about 2000. For product sold in the customer who last year but not this year. Okay. Find customers who only buy products from category 2 and never buy from other categories. Okay, so if you have this information, this use case, find customers who only buy products from category 2 and never buy from other categories. Read the PPT. Okay, yeah. Assume this is your use case. Okay, so when you get the use case, right, maybe this is simple use case. Don't assume that it's uh, how complex use case. So assume that you got this use case. So when you get this use case, right, so you never jump immediately into technical solution. Okay, so remember this. Don't get into technical solution. So don't assume, right? I can say select customers. So immediately I can say customer ID or customer name. Okay, from table, customer table, where suppose category code equals to 2. And then never buy from other categories, how to write, and category not equals to 2. Don't do something like this. Okay, no, never jump into technical solution. So first write down the algorithm. So how to do this? Okay, so when you are ready with this, right, customers who only products, something like this. So I know that the information is available in customer table. The customer details are available in customer table, and the product details are available in product table. Yeah, this is another table. And since he's saying buy from other categories, something like this, so the sales information is available in sales table. And then how to get the information, what kind of products he purchased, something like that, a particular customers details I want, right? Customer name, customer name, ID, something like that. So how to get the that information? So product information, I know with the product ID, and sales information is with the product ID. Okay. I can get the sales information by joining these two tables by product ID. Okay. After that, I can get to know that whether this particular products, okay, so which is been belongs to category 2, okay, or which category, whether it is category 2 or something else. Okay. So once I get this information, I can join product table and customer table based on some customer ID. I'm not sure, maybe that will be there. Sales order, we have product ID, and then product, we have product ID, but we do not have customer information anywhere. Here, do we have customer ID? Here also, we do not have customer ID, sales order ID, product ID. But how to get the customer information? Yeah, maybe that is irrelevant now. Okay, we'll get to know how this has been. Customer ID, sales, product customer address, product category, product description. Yeah. So in this particular table, we have customer ID, maybe this sales order header and sales order detail. It will be having some relation between these two, sales order ID and sales order detail ID. Okay. So sales order ID. So here with this and this, we can get that. So again, you need to use that particular sales order ID header table over here, and we can get that information. And after that, I can select whatever is required for me, customer name, customer ID, something like that. Okay. So if you jog on your steps like this, then you can apply this particular uh, algorithm, being it in SQL, Unix, or PySpark. Okay. You can simply apply that condition over there. Okay. So that's how you will need to learn. So I think I took some um, bad example, but I'll tell you how to read the use case and how to write this algorithm and how to implement into the technology. Okay, so that's how your learning should be. So that it's very easy to solve the use case. Okay, so this is how I follow. And why I'm saying this, when you get the use case right, you never go to ChatGPT directly. You will get the output. You'll get the logic and you can implement it. But you have to think, right? Just you have to think, and you for thinking purpose, you need to create this algorithm. So if you say something like this, but for this, you need to give your DDLs. DDLs means how your tables looks like. So how exactly this will give you the solution. Okay. Okay. So I'll stop here. It took longer time. Actually, I thought of discussing this as well. Yeah, I'll stop here. I'll continue tomorrow, and I'll start with this set operators. And this is how you can practice. You can practice your SQL by using this lead code hacker rank. So this will give you the scenarios and everything. And okay, I'll tell you tomorrow. I'll log in and tell you. So this will give you the learning path. Actually, it will give you the tables, information, queries. queries that will give you, and you need to just write there. I'll tell you how to do that and all. So tomorrow I'll start with this, and maybe we'll go with this CTE, which is very common logic and common, the table itself, that concept itself, common table expression. So very commonly we are using that. Okay, that we'll discuss, and if time permits, we'll go forward. Okay, maybe we enter 1 or 2 sessions for SQL, and after that we'll jump into Python. So install your Azure portal, Azure, subscribe to Azure portal and start looking into it, because after 2 classes we'll go to Python. Python maybe 2-3 sessions, and after that I'll jump into ADF. Okay, which is very primary tool for us. Okay, after maybe 11-12 sessions of ADF sessions, I'll take this ADF ingestion framework. Okay, so that time if you are not practicing, it will not give you any worth. Okay. Okay, then we'll connect tomorrow.